So starting with the first one, the probability that report is dry, given that it's actually dry, is by definition equal to the probability that the report is dry and it actually is dry, dividing by what? This is a conditional probability, yes?
Yeah.
So apply the definition.
D. It's all actually dry.
Actually dry, yes. Do we know this piece? Yes. Do we know this piece? Well, but do we know it right now?
Oh, no.
No. But we do know this piece, right? That's right up here. So we isolate what we don't know. And multiply across, as was correctly suggested, 0.7 times 0.6, which is 0.42. And that 0.42 goes up here. And that allows us to fill in one more cell, right? Which one?
Reporting gusher.
Very good. So that's going to happen 18% of the time. It's a really unfortunate situation. The report says it's a gusher, and in fact it turns out to be dry. By the exact same method, we find that the probability that the report says it's a gusher, given that it's a gusher, is equal to the probability that the report says it's a gusher and you actually have a gusher, divided by the probability that you have a gusher. So we multiply across, and we find that the probability that the report says it's a gusher, and it actually is a gusher, is equal to the conditional probability that the report says it's a gusher, given that it's a gusher, times the probability of an actual gusher. And again, these two pieces we have, one is 0.9, and the other is 0.4. So this is 0.36, which goes up here. Do we need anything else to fill in the rest of the table? It turns out that as long as you choose your pieces of information well, 3 pieces of information is more than enough to fill in the entire, or is enough to fill in the entire table. Sometimes 2 pieces, this happens to be enough. So, or even 1 piece, but at least 3 almost always do. So we got 0.54 here, which gives us 0.46 and 0.04. Any questions on creating the table?
What is the 0.46 and 0.54 telling us?
Okay. So if you commission the consulting firm to do a study, there's a 46% probability they're going to come back with a dry report that says that it's dry. You could still have a dry or a gushing field, but that's the probability just of getting a dry report.
Okay.
Similarly for the other. So think about the process here. What's going to happen in terms of what happens with the report and what happens with your decision to drill and when you get paid? What happens first? Do you decide to drill first?
No. Report.
Okay, so first you decide to get the report, and then you get the result of the report, right? And then you decide whether or not to. Right, okay. So that's our new structure. And the 2 things that can happen are that the report can say we're dry, or the report can say it's a gusher with these two probabilities. Right? Now, if the report says it's dry, we have a decision to make. What are the two things we can do?
Drill or not drill?
Drill or not drill. If we don't drill, what's our payoff?
Save money.
0.
Yeah.
If we drill, two things can happen. What are they?
Dry
It can
to gusher.
actually be dry or actually be a gusher, right? So we've got actually dry or actually a gusher. Now, if it's dry and we've drilled, we lose 30. If it's a gusher, then we get 100. The question is, what's the probability that it's dry? This is the key. This is the
0.46.
application of Bayes.
42.
Dave?
42.
0.46 times 0.42?
42
Not quite.
46.
You're on the right track, though. You're looking at the right things. We know, right? We know that the report was that it was dry. Yes. So we know that we're in this row. Yes. Now, out of these 0.46, 0.42 represents when it's dry. So what we're looking for is the conditional probability that it's dry, given that the report says it's dry. Yes? Okay, so we want the probability that this thing is actually dry, given that the report says it's dry. And is it obvious to everyone that those two animals are very different things? So here we have, by definition, the probability that it's dry and the report says it's dry, divided by the probability that the report says it's dry. So that's 0.42 divided by 0.46, or 0.913, which goes here. And the probability that it's a gusher, given that the report says it's dry, is much easier to calculate. That's just, what?
Gush.
What's that?
Gusher.
Yes. The number? What is the probability that the report says that it's actually a gusher, given that the report says it's dry?
1082.
1 minus this, right. So 1 minus 0.913 is 0.087. I know that was very, very small. Can everybody read this? Okay. Let me do it here. 1 minus 0.913 is equal to 0.087.